Hello and welcome. In the last video, we talked about how to use parent functions to graph transformed functions and how to identify those transformations when we're looking at the function as opposed to looking at the graph. In this video, we're actually going to transform functions. So we're going to start with a function and we're going to talk about how does that impact the function from the equation sense if we translate it up or down or stretch it or shrink it. What does that look like in the function as opposed to just in the graph? So let's go ahead and jump right in. So we talked a little bit about HIVO, which is a mnemonic that I use that helps me remember what order things are happening in and where those things happen. But let's just recap that a little bit right now. The high part of HIVO is that horizontal things, they happen inside the function. And they are also the inverse of what you think they should be. So if it says plus 3 in my head, that means I should be going 3 to the right. But it actually means that I'm going 3 to the left. So horizontal is the inside part, and it's the inverse of what you think. So if I have f of x minus h, and this is what I mean by inside. You'll see this happening inside absolute value or inside something being squared. If it says plus h, that means that I'm moving h to the left. If it says minus h, that means I'm moving h units to the right. So the inverse of what I think. Horizontal stretches and shrinks, again, they happen inside the function, so you're going to see a coefficient in front of your variable x that's being multiplied by 2 or multiplied by 1/2. And what's happening is that we're going to have a stretch or a shrink by a scale factor of 1 over a. So if, let's say it was the absolute value of 2x, this would be a horizontal. Remember, horizontal happens inside and it's the inverse of what you think it should be. So in this case, it would be a shrink by a scale factor of 1/2. And then lastly, on horizontal, if we are reflecting, what we're really doing is we're having a negative on the inside with x. So every x in the problem, you're going to replace that with negative x. That's how we would reflect in the y-axis. All right, now let's talk about vertical. Vertical happens outside the function, and it's the original. It is what you think it is. If it says plus 2, it's up 2. If it says times 2, it's a stretch of 2. So if k is positive, where we have f of x plus k, if k is positive, k means up k spaces. Negative k means down k units. If there's a number outside the function being multiplied, that's a stretch. So if we had the absolute value, 2 times the absolute value of x, that would be a vertical stretch by a scale factor of 2, versus if we had 1/2 times the absolute value of x, that would be a vertical shrink by a scale factor of 1/2. So it is what you think it should be. And then with reflections, the reflection is going to happen outside the function. So it's like you're taking the opposite of each part of the function, and that negative sign will show up on the outside. A really good question was asked the other day about how do we know if we're just looking at the graph, how do we know if something is a horizontal stretch or a vertical stretch? It was such a great question because the short answer to that question is if all you have is the graph, these two graphs are identical. These two graphs are identical. And what I want you to notice is that the equations above them, the functions, are different. You cannot tell from a graph if something is vertically stretched or horizontally stretched. They look the same on the graph. So you won't be asked to identify that kind of transformation from a graph, or if you were, there would be 2 correct answers. You could say that this graph is vertically stretched by a scale factor of 2, or that it's there's a horizontal shrink by a scale factor of 1/2. So just keeping that in mind, stretches and shrinks visually are hard to identify, but looking at the function is where we can identify those. So now that we've reviewed HIVO and what these transformations are and which parts of the function they affect, instead of identifying transformations, which is what we did last class, we're actually going to perform transformations. We're going to write a transformation on a function. So let's look at some examples. So we're going to start writing transformations on generic functions. So notice we aren't talking about, on any of these 4 examples, it doesn't say that we're talking about the parent function x squared or the parent function absolute value of x. It just says that we're writing a transformation in function notation. So we're going to write g in terms of f. So for each of these problems, we're still going to be considering and thinking through the idea of high-vo. So we're going to start by saying g of x is something, I'm doing some things to f. So I'm going to really try and use color to help you see each of these things, and I'm going to rewrite up here high-vo because I want you to be thinking through that. Translated, g of x is translated 4 to the left. Now horizontal happens inside, and it's the opposite of what you think it should be. So inside, left 4 means plus 4. Horizontal happens inside, and it's the inverse of what you think it should be. Then down 2. Vertical happens on the outside, and it is what you think it should be. So I'm taking g of x, and I'm saying to get g, I plug in x plus 4 everywhere that there's an x, and I subtract 2. This is the function notation description of the transformation. So really what we're doing is we're describing in notation what the sentence says in English. So we're going to translate this sentence as well. G of x is going to be some transformation of f. Reading through, translated 1 unit to the right. So that means inside, because horizontal happens inside. 1 to the right means minus 1. It says it's reflected over the y-axis. Over the y-axis means that x becomes negative x, so I'm going to stick a negative inside there. And then translated up 2 means I'm going to have plus 2 here. So I'm going to encourage you to pause the video and see if you can work through number 3 on your own. If you find number 3 to be pretty straightforward, try number 4, and then unpause the video and see how you did. Okay, hopefully you had time to work through these 2 problems on your own. I'm going to just start by saying I'm writing out g of x as stuff happening to f of x. G of x on number 3 has a vertical stretch by a scale factor of 5. Vertical happens outside, and it's the original, so I'm multiplying the whole thing by 5. And I'm translating it up 9. So that also is vertical. Up and down is vertical, and it's happening outside the function. So g of x is really 5 times the function f of x plus 9. So I could find each x value by applying this transformation. Number 4, g of x has a horizontal stretch of 5. So horizontal happens inside, and it's the inverse of what I think. So even though it says 5, what it really means is 1/5 is being plugged in and is being reflected over the x-axis. X-axis is outside the function, so I'm going to put a negative sign in front. So the idea here, translating the English into function notation. And we don't have a function, we just know we're calling the function that we're applying this transformation to, we're calling it f. What we're going to look at next is what happens if we do know what that function is called. How does that change what our new notation is going to look like? All right, so here we go. The very first thing I'm going to have you do is I'm actually going to have you ignore part of these directions. I want you to temporarily not see what this function is, and I want you to practice what we have been doing on the first 4 examples. So I'll show you what I mean on number 5, and then you can pause the video and do that first part on 6, 7, and 8. So the first thing the directions ask us to do is write g of x as a transformation of f of x in function notation. So just exactly what we were already doing. So here, translation to left would mean plus 2 on the inside. Translation down 1 would mean minus 1 on the outside. So go ahead and pause the video and do that step on 6, 7, and 8. Now we are going to have to come back and do another step because it says then apply the transformation to write the function g. Right now we're writing g as a function of f, but eventually we're going to be writing g as a function itself. So go ahead and pause the video and work through 6, 7, and 8, just the function notation part on your own. So here we go. On number 6, there's a horizontal shrink of 1/3, which means there's going to be a 3 inside. There's a reflection over the x-axis, which means a negative in front, and translated down 2, which means minus 2 on the outside. For number 7, there's a horizontal stretch of 2, which means I'm plugging 1/2 in. There's a reflection over the y-axis, which means this is negative. I need to fix this so you can see that. There we go. And a translation up 4. And then last but not least, a translation 2 units to the right, a vertical stretch by a scale factor of 1/3. And that's writing each of these functions, g, as a transformation of f of x in function notation. What we're going to focus on next is how to apply the transformation to a function. So I know I said that we were temporarily going to ignore that they were giving us a function, but I'm going to unignore that now. I guess I should erase so we can see those. And we're actually going to apply the transformation that we just wrote in notation, function notation, to the function. And the nice thing is, really all that means is the function is the absolute value of x for number 3. So instead of saying f of all of this, that f is going to change into absolute value. Everything else is going to stay the same. So I'm still going to have x plus 2 on the inside. I'm still going to have minus 1 on the outside, but now we're calling this function the absolute value graph. So we can say this is the function notation description, but this could be graphed on a graphing calculator. It could be graphed on Desmos. This is the transformed function. So same thing on number 6. Our function is x squared. So where it says f, that's going to become our function squared. So g of x equals, I'm still going to have a negative in front. I'm still going to have 3 and x on the inside, and I'm going to have minus 2 there. Go ahead and pause the video and see if you can do 7 and 8 on your own, and then unpause the video and see how you did. All right, so on number 7, our function is absolute value. So I'm going to take this f parentheses. That whole thing is going to become absolute value. So g of x is equal to the absolute value of negative 1/2 x. And then outside that absolute value is still plus 4. So again, we're really focusing on generically what's happening to the function versus writing it as a function that could be plugged in and graphed. I can't plug in numbers and graph on this first function that's still in function notation because it has an f, but we could do it into this function here. Okay, on number 8, the actual function is x squared, so I'm going to replace this f parentheses with parentheses squared. So g of x is going to equal 1/3 times the quantity x minus 2 squared. Now, just as a reminder, according to the order of operations, we do exponents before we multiply. So we can't distribute this 1/3 in. That would be violating the order of operations. We're just going to leave it exactly like this. And next chapter, when we start talking about quadratics, we're going to talk about how it being in this exact form actually makes it a lot easier for us to graph. Okay, the very last thing we're going to do, we're going to add one more layer onto this idea of writing a transformation, and that is going to be order. Sometimes, as we were looking at in these examples, everything is just a list of things that we need to do to the function. But sometimes we're going to have to do something and then do something else, and the order that we write it in matters. So before we look at these last couple examples, I'm going to just refresh your memory on what order we should be writing these transformations in. So when we're listing our transformations, so if I'm looking at a function and I'm listing out the transformations that are happening, the very first thing that we're going to do is we're going to list those horizontal first. Anything that's happening horizontally. So horizontal is going to get listed first. Within that, we need to make sure that we're following the correct order. So I'm going to just write something here, 2x plus 1 quantity squared. And I guess I should give this a name. If I was describing these transformations, I'm going to list them in the order. I'm going to almost pretend like this is equal to 0. I'm going to list those transformations in the order that I would do to solve for x. So if I was solving for x on the inside, the first thing I would do is subtract 1. So I'm going to list my translations left and right. Those are going to be listed first. So I'm going to actually, the first thing we're going to do is list horizontal translations. Then, after I got here, and again, we're not actually solving, but this just helps you understand the order, the why of what you're doing, the order that we're listing everything in. The next thing I would do is divide by 2. So the next thing I'm going to do is list my stretches or shrinks. And then the last thing I'm going to do is list my reflections. The way that would show up in the function is if I had a negative on the inside. So after I would technically divide this by -2, but the negative I would be dealing with last. So reflections last. So always start with your horizontal transformations. List the translations, list the stretches and shrinks, list the reflections. Then move on to your vertical. So after you've listed all of the horizontal things that are happening, then you're going to list your vertical things. And you're going to list them in the order. I'm going to change this up a little bit. You're going to list them in the order that you would do things to x. So the first thing, if I told you plug in 0, the first thing that you would do is square that number. That's the function. Then you would multiply it by 2. So the first thing that we list vertically is going to be stretches or shrinks. Then, if there was a reflection here, reflections. And then the last thing that we'll list are translations. So it's actually sort of the opposite of what we did with horizontal. So before, I'm going to just create an example right here and make sure that we understand what we're saying here. I'm going to use a different function. I used quadratics before. So let's say, g of x equals 2 times the absolute value of -x plus 1 minus 5. So I'm just going to make up a function here, and we're going to make sure that we understand how to list these transformations in order. So the first thing I'm going to ask myself is, am I translating horizontally? Yes. This -1, I'm going to list that first. This means translate left 1. The next thing I'm going to list is any reflections, stretches, or shrinks. So there's no stretches or shrinks horizontally. There's no inside stretches or shrinks. There's just this negative inside, and that is a reflection across the y-axis. Then I'm going to go to vertical. Stretches or shrinks, yes, there is a vertical stretch with a scale factor of 2. And vertical translations, we're translating down 5. That's the order that you should be listing. So deal with all the horizontal stuff first, translations, then stretches and shrinks, then reflections. Then deal with the vertical stuff, stretches and shrinks, reflections, translations. That order is really important. And why I wanted to talk about this before we get into our last few examples is because I want you to keep this in mind while we look at these examples, how important order is. So let me go ahead and get those examples up for us. All right, I made those smaller so that we can keep looking at them while we talk through these last 2 examples. So the big difference in these problems is that now we're going to have a sequence. The order is going to be even more important than it was in the last few examples. And the indicating word that's going to tell us that order is crazy important is this, I guess I should say words, followed by. Followed by means I need to do something first, and then after I do that, I need to do something else, and that something else applies to everything that has already happened. When you're looking through these problems, if the order that we're doing the transformations, if that order matches the order that we're supposed to list them, we're not going to have any issues. If that order doesn't match, then that's where we really need to make sure we're applying the change that is being said. We're applying the change that we're being told to apply. So let's look at number 9. We're being told that f of x is the absolute value of x. I'm going to come back to that and deal with it last because we're also being asked to write the in function notation first. So g of x is some transformation of f of x. We'll see what we're doing to it. Now reading through, there is a horizontal stretch by a scale factor of 4. Horizontal happens inside, and it's the inverse of what we think it should be. I don't think I saved myself enough room there. So horizontal stretch of 4 means I'm plugging in 1/4, and that's going to go with my x. And a translation 2 units down. So that means -2. Now here's the word that makes us question all things, followed by a reflection in the x-axis. So what I'm asking myself now is, all these things that I have to do to this function, are they already listed in the correct order? So there were no horizontal translations. There was a stretch and shrink that should have been listed first, and it was. There was no reflection in the y-axis. Vertically, there were no stretches and shrinks, but the reflection is listed last, which means that reflection is coming after I have translated. So what I want you to think about is I'm taking something and I'm moving it down too, but then I'm reflecting it across the x-axis afterwards. That's going to change something that was to something different. It's going to change the sign of that final result. So what I need to do is I actually need to put brackets and have a negative in front. The entire function is being affected by this reflection because it happens last. So if I just clean this up a little bit, negative f of 1/4 x, this negative sign is going to distribute and make that negative to a positive. So here's the function notation version. Now let's just plug in the function that we're talking about. G of x is negative the absolute value x, keep the inside the same, and keep the outside the same. So always asking yourself about the order. Is it in the right order? If not, how do I make sure that I'm impacting my function in the correct way? Okay, number 10, g of x has a vertical stretch by a scale factor of 2, vertical stretch by a scale factor of 2, followed by a translation right 2 and down 5. So the only thing that's happening horizontally is that we're moving right 2, which means that it doesn't matter that that wasn't listed first. It's not being impacted by this 2 on the outside, so I can just put right 2 on the inside. Now, everything else is in the right order. We stretched and then we translated down, so I can translate down last afterwards because the vertical stuff was in the correct order. So I don't have to make this second adjustment and worry about this extra negative sign or distributing. So I'm going to put a smiley face here. We're happier because this was listed in an order that was less confusing. We don't have to worry about things being out of order. Let's look at a couple more examples and then we will wrap up this video. All right, here we go. G of x has a reflection. So I'm still doing f of stuff to x. A reflection in the x-axis, which comes out in front, followed by, after this, a horizontal stretch by a scale factor of 4. Horizontal stretch, and that's the only horizontal thing that's happening. Horizontal stretch by a scale factor of 4. Since there's nothing else that's horizontal that's listed, we're okay on our order. We can just put 1/4 in here. And a translation 2 units down. So this happens after we reflect. So after we reflect, we're going to put -2. Again, I'm asking myself, is this in the right order? We dealt with all the horizontal stuff. There was only one thing, so the order wasn't super worrisome. And then here, there were no stretches or shrinks. There was a reflection. The reflection was listed before the translation. So our order is right, and we don't have to worry about mixing that up. If we write this using the function that's given to us, absolute value of x, we're going to have negative absolute value of 1/4 of x minus 2. And again, both of these are required in your solution because the question says write the transformation in function notation, that's this top one, then apply the transformation to the function, that's the second part. So both pieces are essential. Okay, I encourage you to pause the video and try and work through number 12 on your own and then unpause the video and see how you did. All right, hopefully you had time to try and work through this on your own. G of x is translated 2 units to the right, and here I'm going to have -2, and down 5, followed by a vertical stretch by a scale factor of 2. So horizontally, there's only one thing to list, and that thing is correct on the inside. But vertically, the first thing that was listed was the translation. That's supposed to be last. What that means is this vertical stretch of 2 is going to impact the entire function. So I can rewrite this as g of x is 2 times f of x minus 2. I'm going to distribute that 2 to the 5 to get -10. And then if I plug in x squared, which is the function, 2 times x minus 2 quantities squared minus 10. Now I want to do one more example because I want you to see what happens if we have something in the wrong order with the horizontal. I think these examples did a good job of showing what happens if we have something in the wrong order vertically, but let's see what happens if we have something in the wrong order horizontally. All right, so we're gonna stick with generic functions. G is being transformed from F, and I'm not even gonna put a final function in afterwards. So there is a horizontal shrink by a scale factor of 1/4. What that really means is you're taking every x and you're replacing all of those x's with 4x, because horizontal shrink means inside, opposite of what you think it should be. So every x is becoming 4x. Actually, I'm going to give myself a little bit more room here. After we shrink everything by a scale factor of 1/4, meaning we multiply everything by 4, after we do that, we are translating everything to the left 2, which means after x turns into 4x, then x is turning into x minus x plus 2. So what that means is, since it was out of order horizontally, I need to add this extra set of parentheses, which I could distribute to get 4x plus 8 if I wanted to write it in a more simplified way. But because the 4 happens first and then we translate, this needs to be written in such a way that each piece is affected. So key ideas in this section. First of all, we really focused on this HIVO. Horizontal stuff happens inside, and it's the inverse or the reciprocal of what you think it should be. Vertical stuff happens outside, and it is what you think it should be. So you should be able to look at a function, and this is what we focused on in the last video, and identify the transformations from that function. You should also, the new idea today, be able to transform a function. If I tell you you're going to move it right and down or stretch it or shrink it, you should be able to perform that transformation on the function both in function notation. So when we're saying function notation, we're meaning you still have g of x in terms of f of x. And then you should be able to substitute in whatever the function is, if we're given one, to rewrite it in terms of that specific function. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.